Let's take a look at the first four layers of the OSI model. These are referred to as the data flow layers: the physical layer, the data link layer, the network layer, and the transport layer. The physical layer is concerned with moving bits from source device to destination device. The movement of bits across media. It's another key word there. Notice I'm listing keywords here: bits, media. Now this media is cables and connectors and pinouts. The actual pinouts, the actual physical implementation that will be involved here at the physical layer to move the bits or the electrical signals from source device to destination device. Also include electrical signals here. A few protocols and standards involved at the physical layer include EIA TIA 232. This is a serial cable standard. This is also referred to as RS-232 or Recommended Standard 232. Another serial cable standard is V35, V.35. A couple of other standards we could plug in here that you might be familiar with would be Cat5, Cat3, Cat2, etc. Also the connectors such as RJ45, RJ11, etc. Any of those physical aspects of the media would be included here at the physical layer. Troubleshooting always begins at the physical layer, being sure that I have electrical signals actually being received by the device. The data link layer is subdivided into two sublayers. These include the MAC sublayer and the LLC, the Logical Link Control sublayer. The data link layer is concerned with combining bits into bytes and bytes into frames. So bits into bytes, bytes into frames. Keyword here, frames. Another keyword to include here at the data link layer would be MAC address, Media Access Control address, the MAC address itself. The MAC address is a 48-bit address that is burned into the NIC card on a device when that NIC card is born in the NIC card factory. Another name for this might be hardware address or Ethernet address or BIA, burned in address. The key point here to note is that different places in the Cisco IOS might refer to the MAC address in different ways: the hardware address, Ethernet address, or BIA, burned in address. A few protocols and standards to include here at the data link layer. On the LAN side, as far as LAN frame types would include 802.2. This is your logical link control right here. 802.3, that's Ethernet. 802.5, that's token ring. And we'll just throw in 802.11, that's your wireless standard. There are some other standards that can be included here, but I just threw out a few for example. Some of your WAN standards or WAN encapsulation types include the default encapsulation type on a serial link, which is HDLC, high-level data link control. Another encapsulation type for your WAN or your serial cable would be PPP, point-to-point protocol. PPP would be used whenever you're needing to go between different vendors across the same serial link, say for instance between a Cisco router and a Nortel router. And then of course another example would be frame relay, and a couple of protocols or a couple of standards that we could mention at layer 2 would be ISDN and ATM. Layer 3, the network layer, provides logical addressing which routers will use for path determination. So as opposed to the hardware address that you have here at layer 2, you have a logical address here at layer 3. Example of that logical address would be one protocol, IP, for IP address. The IP address would be a logical address. These logical addresses provide a hierarchy, a hierarchical approach to being able to determine exactly where a device is or exactly where a packet is destined to. So logical addressing, which routers use for path determination, that's another key word. Logical addresses for path determination to route, that's another key word, and packets to route packets. Examples, as I mentioned, as far as protocols are concerned, would be IP, IPX, which is used by Novell, and a couple of others that we could mention would be AppleTalk, and you could also throw in an older protocol, DECnet. Part of the IP protocol suite would be ICMP, ARP, and RARP, Reverse Address Resolution Protocol, Address Resolution Protocol, and Internet Control Messaging Protocol. ICMP is what we use for ping messages. Probably all familiar with pinging a device for troubleshooting purposes. The transport layer provides us with reliable or unreliable transport of segments. Reliable or unreliable transport of segments. Now, why would I want unreliable transport if I could have reliable transport? This brings us to the topic of connection-oriented protocols versus connection-less protocols. So we'll just say connection and connection-less there. Connection-oriented protocols are reliable. In other words, they provide a few mechanisms built into the segment format, the header itself, that provide reliability, such as the sequence number and acknowledgement number, and also there's retransmission if a particular segment is not received. Unreliable communication is where the segment or the packet is simply sent without any acknowledgement. Reliable communication would be used in examples like file transfer or with email or something like that. An application that requires all of the data to be received in sequence and in order. Unreliable communication or connection-less communication would involve a real-time application such as streaming video or streaming audio. This type of application would not need an acknowledgement, nor would you want a retransmission. Examples of connection-oriented protocols would be TCP, Transport Control Protocol, and also SPX. SPX is used with IPX, of course, for Novell. And then an example of a connection-less protocol would be UDP, User Datagram Protocol. So that provides us with a look at the lower layers of the OSI model, referred to as the data flow layers. The data flow layers are the layers that routers and switches would be most concerned with. In this particular course, we're going to be focused most on the data flow layers for troubleshooting purposes and understanding how data is encapsulated between those layers.